Introduction to Matplotlib. Matplotlib is a popular Python library for creating visualizations. It is used to generate charts, plots, and graphs. Real-world uses include visualizing data, trends, and results in science, business, and research. Matplotlib makes it easy to turn data into pictures and diagrams. Running the cell now. This line hides warning messages. This imports the main plotting functions from Matplotlib. This imports numpy for working with arrays of numbers. To install Matplotlib on Windows, open Command Prompt and run. Pip install Matplotlib. Running the cell now. This code sets up the environment by importing Matplotlib and numpy, essential libraries for creating visualizations and handling data. Although there's no visual or textual output yet, this is the foundational step before plotting graphs, highlighting how to prepare your workspace for using Matplotlib in data visualization. Core concepts in Matplotlib. Matplotlib uses figures and axes to build plots. A figure is the whole window or page for your plots. Axes are the individual plots inside a figure. The PyPlot module provides an easy way to make plots. You can customize plots with labels, titles, and legends. Data is often provided using numpy arrays or Python lists. Running the cell now. Beginner example 1, your first line plot. Let us start with a simple line plot. We will plot a list of numbers. Running the cell now. This is a list of numbers we want to plot. This draws a simple line through the data points. This displays the plot window. Running the cell now. This output shows a simple line plot of the list 1, 3, 2, 5, 7, illustrating how the values change over their positions in the list. Notice the general upward trend with a dip at the third value, demonstrating how Matplotlib connects points in order. This confirms we can easily visualize a sequence of data with just one line of plotting code. Beginner example 2, adding titles and labels. You can make your plots easier to read by adding labels. Let us add a title and axis labels. Running the cell now. Draws the line plot again. Sets the main title for the plot. Sets the label for the horizontal axis. Sets the label for the vertical axis. Shows the labeled plot. Running the cell now. The output shows a simple line plot titled Simple Line Plot with clearly labeled x-axis, index, and y-axis, value. Notice how these labels help clarify what the data points represent, making the plot easier to interpret. This demonstrates the key lesson of enhancing readability by adding meaningful titles and axis labels. Beginner example 3, plotting two lines. You can plot multiple lines on the same graph. Let us see how to display two data series together. Running the cell now. X values for the plot. First set of Y values. Second set of Y values. Plots the first line and labels it. Plots the second line and labels it. Sets the plot title. Labels the x-axis. Labels the y-axis. Displays the legend for both lines. Shows the plot window. Running the cell now. This plot shows two lines on the same graph, allowing you to compare their trends over the x values. Notice how line 1 generally increases with some fluctuation, while the line 2 remains flatter, highlighting differences between the two data series. This demonstrates how plotting multiple lines together helps visualize and compare datasets effectively. Intermediate example 1, scatter plots. Scatter plots help you see individual data points. Let us plot random points to see how a scatter plot looks. Running the cell now. Sets the random seed so the results are repeatable. Generates 20 random x values. Generates 20 random Y values. Plots red points for each x, y pair. Sets the plot title. Labels the x-axis. Labels the y-axis. Shows the plot. Running the cell now. This scatter plot shows 20 randomly positioned red points spread across the plot area, illustrating how individual data points are displayed with their exact x and y coordinates. Notice the even distribution without any clear trend, which matches the intent of visualizing random data to understand the basics of scatter plots. Intermediate example 2, bar charts. Bar charts are useful for comparing values. Let us plot a bar chart of some categories. Running the cell now. Names of the categories. Values for each category. Draws green bars for each category. Sets the plot title. Labels the x-axis. Labels the y-axis. Shows the bar chart. Running the cell now. This bar chart visually compares the values across for categories, with B having the highest value and C the lowest. Notice how the height of each green bar directly represents its value, making it easy to see differences at a glance. This reinforces the lesson's point that bar charts are effective for comparing categorical data. Intermediate example 3, saving your plot. You can save your plots as image files. Use savefig before plt.show to save the image. Running the cell now. A simple list for x values. A simple list for y values. Plots a basic line. Sets a title for the plot. Saves the plot to a file named my_plot.png. Shows the plot. Running the cell now. This output confirms that the plot was created with a clear descending line from E15 to 51, showcasing the data trend. Importantly, the use of plt.savefig my_plot.png before plt.show ensures this plot is saved as an image file named my_plot.png, illustrating how you can preserve your visualizations for future use or sharing. Advanced example 1, subplots. You may want to display multiple plots in a single window. Subplots help you organize plots in a grid. Running the cell now. Creates a figure with two side-by-side plots. First subplot draws a line for square numbers. First subplot sets the title. Second subplot draws a line for cube numbers. Second subplot sets the title. Adjusts layout so nothing overlaps. Shows both plots in one window. Running the cell now. This output shows a single figure containing two subplots side by side, demonstrating how to organize multiple plots in a grid layout. The first subplot visualizes square numbers, and the second displays cube numbers, highlighting how subplots help compare related data within one window efficiently. Notice how each subplot maintains its own title and axis, keeping the presentation clear and organized. Advanced example 2. Customizing plot styles. Matplotlib lets you change the look and feel of your plots. You can choose styles, colors, and markers. Running the cell now. Changes the plot style to plot. Creates 100 evenly spaced points from 0 to 10. Calculates the sign of each x value. Draws the sine wave with circles, purple color, and dashed lines. Shows a legend for the line. Sets the plot title. Shows the styled plot. Running the cell now. This styled sine wave plot uses the subplot style to give a clean background and grid, while the purple dashed line with circle markers highlights the wave's peaks and troughs clearly. Notice how the custom marker, color, and line style enhance the visual appeal and make key data points stand out. This demonstrates how Matplotlib's style and plot customization options allow you to tailor your visuals for better clarity and presentation. Error handling example: what happens if data lengths differ? Matplotlib expects X and Y data to have the same length. Let us see what error we get if they do not match. Running the cell now. Start a block to catch errors. Try to plot lists of different length for X and Y. Show the plot if it works. If an error occurs, catch it. Print the error message. Running the cell now. The error message highlights that the X and Y data arrays have different lengths, 3 and 2 elements respectively, which Matplotlib cannot plot together. This reinforces the lesson's point that X and Y inputs must be the same size to produce a valid graph, demonstrating how Python raises a clear, informative error when this rule is broken. Debugging tips. Check your data sizes before plotting. Use print to display your X and Y values. If your plot does not show, remember to use plt.show. Running the cell now. Example X values. Example Y values. Prints the X values. Prints the Y values. Plots the values. Shows the plot. Running the cell now. Here, the printed X and Y lists confirm that the data points are correctly set for plotting, matching the expected lengths and values. The line plot shows a simple linear trend from 1 for 2, 3, 6, verifying the data inputs. Remember, printing the data and using plt.show ensures the plot appears as intended, reinforcing key debugging steps. Best practices. Always label your axes and add a title. Use legends if you plot more than one item. Save your plots before calling plt.show. Use plt.type_layout to avoid cut-off labels. Choose clear colors and styles for lines. Running the cell now. Creates an array from 0 to 4. Calculates square values. Calculates cube values. Plots the squares in orange with a label. Plots the cubes in blue with a label. Labels the x-axis. Labels the y-axis. Adds a title. Shows a legend. Adjusts layout. Shows the finished plot. Running the cell now. This plot clearly shows two lines, the orange one representing squares and the blue one representing cubes of the x values, with both axes properly labeled and a descriptive title. Notice the legend differentiates the lines effectively, and the use of plt.type_layout prevents any label cutoff, illustrating the best practices for clear and professional plotting. Though the output message indicates the figure creation, the key takeaway is the readable, well-organized visual ready for saving or presentation. Mini project, visualize monthly sales data. Let us use what we have learned to plot sales data. We will use bar charts and a line showing the average. Running the cell now. List of months. List of sales numbers for each month. Calculates the average sales. Draws a sky blue bar for each month's sales. Draws a red dashed line for the average sales. Labels the x-axis. Labels the y-axis. Adds a title to the chart. Shows a legend for the bars and the average. Adjusts the layout. Shows the sales chart. Running the cell now. This plot displays monthly sales as blue bars, making it easy to compare performance across the first half of the year. Notice the red dashed line representing the average sales, which helps highlight months performing above or below this benchmark. This visualization reinforces how bar charts combined with an average line can provide clear insights into trends and variations in sales data. Thank you for learning with us. Like and subscribe for more Python tutorials. See you in the next video. Running the cell now.